Are we alone? It's probably one of the biggest questions humanity asks itself, isn't it?
Absolutely. It feels ancient, almost primal, looking up and wondering.
And when you get into the actual numbers, I mean, it's just mind-boggling. Our galaxy, the Milky Way,
It's just our local patch.
yeah, we're talking hundreds of billions of stars, maybe 100, maybe 400 billion, somewhere in there.
That's right. And the planets. Estimates suggest there could be tens of billions, maybe 60 billion planets just in the habitable zone.
Habitable zones. So where liquid water could exist. Life as we know it, anyway.
Exactly. The potential is just immense. Think of like every grain of sand on a beach potentially being a place for life.
So that scale, that sheer possibility, it's what makes you think. Surely someone's out there.
Well, for generations, that was the assumption, or at least the hope. And science now shows us the basic ingredients seem pretty common out there. Energy, elements, stable spots.
Right. So the universe should be buzzing, shouldn't it? You'd think.
But that's where it gets weird. That's the puzzle.
The Fermi Paradox, named after Enrico Fermi, the physicist.
Right. His very simple, very direct question back in, 1950? Where are they?
Just, where is everybody?
Yeah.
And the answer seems to be silence. A really profound silence.
It's a stark contradiction, isn't it? High probability based on the numbers versus zero actual evidence.
None. After all this time looking.
Decades now, listening with incredibly powerful radio telescopes, scanning for signals, and we found, well, nothing confirmed. It really is like shouting into the Grand Canyon and just hearing your own voice bounce back.
Wow. Yeah, cosmic head scratcher for sure. Okay, so if we dive into this silence, what are some of the ideas? I know one involves robots.
Yes. Self-replicating machines, von Neumann probes, they're sometimes called, after John von Neumann.
The idea is you send out one probe.
Exactly. It travels to another star system, uses the raw materials it finds there, asteroids, dust, whatever, to build copies of itself.
And then those copies travel on and build more copies, like a chain reaction.
Precisely. And the speed at which this could happen is pretty staggering when you think about it cosmically.
How fast are we talking?
Calculations suggest that even starting with just one, you could explore or even kind of populate the entire galaxy in maybe a few 100 million years.
A few 100 million. That sounds like forever.
To us, yes. But the galaxy is billions of years old. It's actually a relatively short time frame in astronomical terms.
Okay, perspective, like planting seeds across the cosmos.
Good analogy, yeah.
But we don't see them. No signs of these super efficient robot explorers.
Yeah.
No signals, no weird artifacts zipping around. Nothing.
That absence is another part of the puzzle. Why wouldn't an advanced civilization use such an efficient method? Which leads to another possibility.
That maybe civilizations just don't last very long.
That's a big one. Maybe advanced societies have inherently short lifespans. They rise, develop technology, and then something happens.
Like fireflies blinking in the night, you mean? If they only flash for a short time, seeing two at once across a huge field is unlikely.
That's a good way to put it. The window for detection might be incredibly narrow.
So what could cause that? Self-destruction, war, climate change, misused tech.
All possibilities. Or maybe large-scale natural catastrophes, asteroid impacts, supernovae nearby, things that could just wipe the slate clean before they get a chance to, send out a galactic, we're here message.
Think about our own challenges.
Yeah.
Like climate change, nuclear weapons. These are serious threats we face.
Exactly. These could be examples of what's sometimes called the Great Filter, hurdles that civilizations have to overcome.
The Great Filter. Okay, let's unpack that. It's like a bottleneck, some incredibly difficult step in development.
Precisely. And the big question about this filter is it behind us or is it still ahead of us? Well, if the Great Filter is in our past, it means something like the origin of life itself from non-life, a biogenesis, or maybe the leap to complex multicellular life. Maybe that was the incredibly hard part.
So if it's in our past, we somehow lucked out. We passed the test that almost everyone else fails.
That's the idea. In that scenario, we might be exceptionally rare, maybe even unique in the galaxy. It makes us seem quite special.
Okay, that's one possibility. But what if the filter isn't behind us?
Yes, the more unsettling possibility that the Great Filter lies in our future.
Meaning life starts easily enough, maybe even intelligence arises fairly often.
But something further down the developmental track stops civilizations. Maybe it's the inability to manage super advanced technology. Maybe it's resource depletion, ecological collapse, self-inflicted destruction, some near universal barrier.
And if that's the case, then our own future might be pretty precarious. We haven't hit the big wall yet.
Exactly. It suggests the hardest part is still to come for us. It's quite a sobering thought.
Definitely sobering. Okay, but what about, UFOs, alien visitations? People claim to see things all the time. Does that solve the paradox?
Well, from a scientific standpoint, extraordinary claims require extraordinary evidence. And while the idea is fascinating, the evidence presented for actual alien visits just hasn't met that high scientific bar. There's no verifiable proof yet.
Right, extraordinary claims. Got it. So another idea I've heard is the zoo hypothesis. Like they're out there, but they're deliberately hiding, watching us.
It's an interesting thought experiment, the idea that maybe there's a sort of galactic federation or just very advanced beings who have a policy of non-interference with developing civilizations like ours were kept in a sort of cosmic nature preserve.
Like Star Trek's Prime Directive, kinda?
Sort of, yeah, but it raises questions too. Could they really hide so perfectly? Especially as our own detection abilities get better and better, it would require incredible coordination and technology to maintain that secrecy across the entire galaxy consistently.
Yeah, keeping a secret that big seems, especially for potentially millions of years. So, okay, maybe they aren't hiding. Maybe. They're just not there. Or very, very few are.
Some more recent estimates lean in that direction, taking into account those potential short civilizational lifespans we talked about.
Right, the Firefly blinking idea.
Exactly. If civilizations only exist and are detectable for relatively short periods on a cosmic scale, the odds of two existing at the same time and being close enough to detect each other, well, those odds drop dramatically.
So maybe the Milky Way isn't teeming. Maybe it's quiet. Perhaps only one detectable civilization right now.
It's a possibility suggested by some models, that one potentially being us.
Us. Wow, that really puts things into perspective, considering the age of the universe.
It does. The universe is, what, nearly 14 billion years old? Life on Earth is maybe 4 billion years old. Intelligent life, like us, a tiny fraction of that.
And our ability to even try to send or receive signals across space, that's barely a century old. A cosmic blink of an eye.
Precisely. We've only just started broadcasting, really. It's entirely possible there were vast galactic empires that rose and fell billions of years ago, leaving nothing we could easily detect now.
Like cosmic ruins, too old and eroded to see.
Possibly. Think about Earth's history. Something like 99% of all species that have ever lived here are now extinct. Extinction is the norm, not the exception. Maybe that applies to civilizations, too.
Okay, another angle. What if we're looking for the wrong kind of life? Or the wrong signals?
A very important point. We tend to search for life as we know it, and intelligence that communicates in ways we can understand, like radio waves. Anthropocentrism, basically.
Assuming aliens would be like us.
Right. But what if they're fundamentally different? What if their biology, their way of thinking, their communication methods are completely alien to us? Imagine trying to explain, I don't know, human society and quantum physics to a highly intelligent squirrel.
Yeah, the communication gap might be just too vast. We wouldn't even recognize their signals as signals.
Or maybe their motivations are utterly different. Consider resource acquisition on a massive scale.
Like galaxy-spanning civilizations needing huge amounts of energy or materials.
Perhaps. And maybe their methods, while efficient for them, could inadvertently wipe out or disrupt emerging life without them even noticing or caring, like paving over an anthill to build a highway.
That's a bit chilling. Does this tie into those Kardashev scale ideas? Type 1, 2, 3 civilizations.
It does. The Kardashev scale tries to classify civilizations based on the amount of energy they can harness. Type 1 uses its planet's energy, Type 2 its stars, Type 3 its entire galaxies.
But where are we on that scale?
We're not even a Type 1 yet, maybe Type 0.73 or something like that, according to some calculations.
Yeah.
We still primarily use energy sources from dead plants, basically.
So a Type 2 or Type 3 civilization would be almost unimaginably powerful from our perspective.
Completely. Their capabilities and maybe even their forms of existence could be beyond our comprehension, which leads to some even more speculative ideas.
Like Matryoshka Brains, what are those?
Okay, so imagine a hypothetical megastructure. Layers built around a star, like nested Russian dolls, Matryoshka dolls.
Okay.
To capture virtually all the star's energy output and use that immense power for computation, running vast, incredibly complex simulations, entire virtual universes.
So advanced civilizations might just retreat into their own simulated realities. They wouldn't care about exploring the physical galaxy or talking to us.
It's a possibility. Why deal with the messy, slow physical universe if you can create perfect, tailored realities internally? They might be utterly indifferent to external exploration or contact, living entirely inside these computational shells.
Wow. Okay, my brain hurts a little now. It really highlights how little we know about the ultimate limits of technology, doesn't it?
Absolutely. We just have no idea what might be possible millions or billions of years down the line. Think how far we've come in just a few centuries, from thinking Earth was the center of everything to mapping exoplanets.
Which brings us back to that idea, the Copernican principle, that we're not special.
Right. The principle of mediocrity, sometimes called. It suggests Earth isn't in a privileged position, our sun is a typical star, our location in the galaxy is unremarkable.
And if we're typical,
Then the conditions that led to us should be typical too. Life and intelligence should be common, assuming the principle holds true.
our sun's a normal G-type star, billions of those in the Milky Way.
Exactly. And we're finding thousands of exoplanets, hundreds potentially in habitable zones. All the ingredients seem to be out there in abundance.
And yet, SETI, the search for extraterrestrial intelligence. Decades of listening.
Decades of listening, yeah. And so far, despite finding lots of interesting natural cosmic noise, no confirmed artificial signals, no hello from ET.
Does that silence challenge the Copernican principle? Does it suggest maybe we are special, or at least very rare?
It certainly forces us to question our assumptions. The Fermi Paradox isn't proof they don't exist, but it's powerful negative evidence. It pushes science to explore all these possibilities we've been discussing. The filters, the short lifespans, the different forms of life, the hiding.
It's a catalyst for deeper thinking. I remember hearing Brian Cox talk about this. His idea was something like, maybe getting to the point of being an interstellar civilization requires solving fundamental problems first, like violence, predation, unsustainable growth.
That's a fascinating thought. That maybe truly advanced civilizations, the ones that last, are inherently peaceful and cooperative, perhaps less interested in aggressive expansion. Maybe the loud, grabby civilizations burn out fast.
So the ones we might want to meet are maybe quiet and stable, not shouting across the galaxy.
It's a hopeful perspective, perhaps, and it aligns again with those updated Drake equation estimates, factoring in civilizational lifespans, suggesting maybe just one detectable civilization per galaxy.
Which currently seems to be us, for all we know for sure.
Based on current direct evidence, yes. Earth is the only planet we know harbors life, let alone technological intelligence. That has to be our starting point, scientifically speaking.
So here in Cosmic Origins Revealed, while we keep searching and keep hoping, the working assumption has to be, we might be it, for now, in the Milky Way.
It seems that way, based on the data we have. The Fermi Paradox remains this huge, compelling mystery. The sheer range of potential answers. Life is rare, life is hiding, life is fleeting, life is fundamentally weird. Just shows how much we still have to learn.
And understanding why the silence is there, it has real implications for us, doesn't it? Especially that great filter idea.
Profound implications. If the silence is partly because civilizations tend to destroy themselves, well, that's a huge warning sign for humanity, isn't it? It underlines how critical it is that we manage our own challenges, our own technology, our own planet. That's a core theme we explore often here at Cosmic Origins Revealed.
Safeguarding our own future becomes paramount. It reminds me of that Carl Sagan quote.
The one about becoming interstellar.
Yeah, that any species that achieves it probably had to overcome its tendencies towards self-destruction, had to learn to coexist.
A powerful thought. It suggests interstellar capability might require a certain wisdom, a maturity that maybe we haven't quite reached yet.
Definitely makes you think. The universe is just vast, mysterious, and awe-inspiring. And exploring these questions like we do here on Cosmic Origins Revealed, it really fills you with wonder.
Absolutely. It's why we do this. And hopefully it sparks that same sense of wonder in you listening. We encourage you to keep pondering these cosmic puzzles along with us here at Cosmic Origins Revealed.
So maybe the final thought for today is, what if that silence isn't emptiness? What if it's just waiting for us to figure out how to listen properly, or maybe even how to join the conversation?
A truly provocative question to ponder.
If you enjoyed this deep dive into the Fermi Paradox and want more explorations of cosmic mysteries, make sure you subscribe to the Cosmic Origins Revealed YouTube channel. We'll see you next time.